Okay, so 3.3, adding and subtracting fractions. We can use math as a metaphor for life because do you see that if you look for similarities, actually math is all about simplifying and looking for similarities. Everything is much easier if you look for similarities, right? So when you have two fractions, we're looking for a common denominator or a similar denominator. In this case, it's already done for you. So if that's the case, if the denominator is already the same, we can just leave it as is. We know that from last year, right? And the year before and all that. Elise?
Can I say the answer?
Yeah, sure. Yeah, exactly. Good. So we end up getting 7 over 7. Good. And as Elise said, that's just equal to the number 1 because we always want to simplify it as much as we possibly can. So far, so good? Good. Okay, so then let's try another one. Let's say we have 3 over 11 plus negative 5 over 11. And don't call it out, but if you know the answer, you can go ahead and write it down. Well, I'll give you a minute. So it's sort of combining integers as well as fractions, right? So it's a couple of different concepts together. Richard? Sure. Negative 2 over 11. Does everybody agree? And see how we got that? So basically, we really just need to worry about the top here. Do you see that this is the same thing as saying just 3 minus 5? And if you have 3 and you're taking 5 away, we end up with minus 2. So yeah, negative 2 over 11 is correct. Good. Okay, so then let's add a little bit more to it. Let's say we have negative 2 over 5, and we want to subtract from it negative 1 over 5, and find what that is equal to. So again, there's a little bit more going on this time. We should make equations of Alex and his McDonald's situation. Alex? Negative 1 over 5 as the answer? Do we all agree? How did we get there? So if you have minus and negative, what actually happens? It's actually like saying plus, right? So the denominator we already talked about, it stays the same. And what's negative 2 plus 1? Negative 1, so Alex is right. It's negative 1 over 5. Good? Questions about that? No? We're good with that? Okay. Okay, let's take a look at something a little bit different. If we have 5 and 2/3, we want to convert that. I don't like how I wrote that. 5 and 2/3. First of all, do you remember what we call that? That's a mixed fraction. We want to change it to an improper fraction. What's an improper fraction? Basically, the numerator is bigger than the denominator. We don't really like those, but sometimes we need that in order to do work. So if we start with a mixed number, can you tell me how I would convert that to an improper fraction? We do 5 times 3 plus 2. Okay, so we're going to say times 3, and then we're going to add 2 after. But that's going to tell us which part of the fraction. So 5 times 3 plus 2, what do we get? At the top, we get a 17, and what remains as the denominator? The denominator stays the same, so 17 over 3 is actually the improper fraction that we would get. Everybody good with that? Yeah. Questions? Am I not even teaching you anything new today? This is review? Some are saying yes, some are saying no. So maybe this is good because it'll hopefully bring everyone to the same place. Because you know how last year was a little bit insane? who knows what you did in your classes or what you had time for. So this is good to get everybody sort of at the same level, right? Now if we start, we're going to do the opposite. I'm going to give you a minute to do this on your own, but if we start with an improper fraction like this, I now want you to change it to a mixed number. Just take a few seconds to do that. Well, is the answer going to be positive or negative? The answer is going to be negative. So we can just sort of shove that off to the side and deal with that separately. Then to get a mixed number, how many times does 4 go into 13? 3 times. Everybody good with that? Then, whatever the denominator is, we know that that stays the same, right? How do we figure out what goes at the top? Yeah, because when we did when we chose this 3, it's because of 3 times 4, which is 12, and then we have the 1 left over. So do you see that we're subtracting in order to get that? Everybody clear on that? And it feels like review? Good? New to some, review for others? I don't know. I feel like based on what you're telling me, we can skip the next few because it seems like you know what you're doing. You're ready for the chapter test? Oh, Alex, that is so painful. That's how you view this? Awful. 4 over 9 minus negative 2 over 3. Well, what would make learning fractions better? Tell me. Nothing? Bring in pi?
Yeah.
Okay, we'll see.
Use the first 20 digits as well. Just use the first 3.
Okay, how do we do something like this then? Now the denominator is not the same, so we have, I guess, one more step really. Alex?
Multiply the right side by 3, because then it makes the denominator 9 as well.
So just by 3?
Both by 3.
Yeah, both the top and the bottom, multiply them by 3. Everybody good with that?
Yeah.
So we get 4 over 9 minus what do we actually, minus, so it's actually a plus, right? And what is this, if we have 2 at the top, what does it become? 6 over 9. So what's the answer after all that? 10 over 9, but we don't like to leave it like that, so what's a better way for us to put that?
1 over 9.
Yeah, it goes in here once, and then the denominator's still the same, and then 10 minus 9 is 1, so 1 and 1/9. Good? Questions so far? Okay, let's say we have 2 3/4 minus 1 1/4. There's actually a few different ways we can do this. You can select whatever you like, but we usually want to pick the easiest way, right? That's what math is, finding the easy path by simplifying. So, what's the easiest way? What do you think is the easiest way?
Just change it to improper.
We can change them both to improper fractions, right?
Yeah, just 2 minus 1.
Is there another way we could do it as well? What's the other way?
2 subtract 1.
2 subtract 1, and what do we get?
1.
1, and then we could deal with these things separately. What do we get?
So it's 3 over 4 minus 1 over 4, you get 2 over 4.
2 over 4, but we don't like to leave it like that, so 1 and 1 over 2. Everybody good with that?
Yeah.
So that's our end result. Do you find this easier, or do you find changing it to improper, subtracting, and then changing it back easier? Depends. Okay, so either method is totally fine. You select whatever you find easiest to work with. Does that sound good and reasonable?
Yeah.
Good stuff. If I write this, do you all know what I am talking about? LCM. What does that stand for? Tracy? Lowest common multiple. Good. Somebody said least common multiple. They both are correct. It doesn't matter, but I'm going to show you one example. Let's say we have the number 5. Can you tell me what the multiples of 5 are? Because I feel like people mix up multiples and what's the other word? Factors. A lot of people mix those up. Multiples, you multiply in order to get them. Maybe that will help you to get a better sense. So what are the multiples of 5? Let's list a few of them.
5, 10, 15, 20, 25, 30.
Okay.
35, 40, 45.
Oh boy, that's good. Good. We get the idea. So basically it's 5 times 1, 5 times 2, 5 times 3, and on and on and on, right? So the multiples are always going to be bigger than the number we're talking about. So if we're talking about the number 5, the multiples are always larger than that. So do you also know that we would call 5 a prime number? What's a prime number? Oh, wow. That was beautiful and confusing and scary all at the same time. So what they were trying to say is, it's a number that only has 1 and itself as a factor, right? So 5 is an example of that. To calculate the LCM, we take the product of prime numbers. Do you remember that?
Yes.
I don't know why. I feel like sometimes LCM throws people off a little bit. So let's say we want the LCM of 18 and 32. We're going to go through this one together. So we want the LCM of 18 and 32. So I'm going to write here 18 and I'm going to write here 32. What times what gives me 18? 2 times 9. I'm going to circle this because that's our prime number. But I'm going to keep going with the 9. Do you remember what we call these things? What is this? Whatever tree? A what tree? A factor tree. Good. And then 3 times 3. So now I have a product of all these primes. I'm going to write them this way. 2 times 3 times 3. And I'm going to put it in a box to say that's the same thing as 18. But that's like 18 written as a product of prime factors. That's how we would say that. Let's do the same thing here. 32, there's different ways, different options, but what times what gives us 32? 2 and 16? Sure, we can do that. So there's 1 prime, and then what times what is 16? 2 and 8? Sure, we could do that. We could have done 4, doesn't matter. And 8 is what? 2 times 4, so there's another one. And then that one is 2 times 2, so there's more. Oh boy, I wasn't planning for that. So we would have, I could say 2, well, how many are there? 1, 2, 3, 4, 5. So there's 2 times 2 times 2 times 2 times 2. Did I get the right number there?
Yes.
Thank you. I really need you to check my work, especially today. Okay, so then if we go back, it says LCM is the product of prime numbers. So when we look at these two, we have, let me rewrite these. Do you see that I can rewrite these to say 2 times 3 squared? That's the same thing. I'm going to put that in a little circle. And then this could be what? 2 to the power of 5. Okay. When we go to find the LCM of these, so LCM, which is what we're interested in, let me explain what we're going to look for in order to find this. I would look at this and I would compare. So see how we have a 2 there and we have a 2 to the 5 there? I would take the larger of those two, and that's the one I'm going to use for my calculation. So I'm going to say 2 to the 5, and I'm going to use, I don't even need to worry about this one because I'm going to go for the larger one. Does that make sense? Then if there's a 3 squared here but nothing here, I need to also include, ooh, that's wrong. I need to also include that in my calculations. Does that make sense?
Yeah.
So what we end up getting, well, what's 2 to the 5 again? Yeah, so it's 32 times 3 squared is 9. And when we multiply that out, we could do that by hand, right? 32 times 9, we could do 9 times 2 is 18. Da, da, da. We end up getting 288 for our LCM. What I want you to get from this is the idea. We break it down to the product of prime numbers. This is one method I'm showing you that I looked through and thought it was the most simplified way to show you. But you break it down to product of prime numbers, then you take the largest of each base and you use that in your calculation. Good?
Yes.
Okay. Do we feel pretty comfortable with that? Okay. Your work. Oh, why does it not say? I don't know. Nice try, everybody. Your projects were due today, people.
Yes.
Well, you said we can stand it.
I'll give you some practice questions, and how about this? If you have free time, you can work on your projects that should have been done today. Sound reasonable? Okay, so it's 3.3, which is on page 105. And you can do numbers 1.
We just have 2 questions, 42.
1 to 8 odd letters. Do you know what I mean by that again? A, C, E, etc.
There's so many.
So this is what I want everyone to do. And this is if you're finished and want a challenge, you can do numbers 11 to 18 for a challenge.